Hello, everyone. So, yes, my name is Katy, and I am here to talk to you all today about Shrek, onions, and architecture. I'd like to give a bit of a self-introduction. So, I've been a developer for over 10 years, probably closer to 15, probably even more than that. And for the past 6.5 years, I have been working with what people like to call big legacy monoliths. 5 years ago, I was working for a company as a platform engineer, and they wanted to migrate their big legacy monolith to microservices, as you do. They realized quite quickly that this wasn't really possible unless they understood what their big legacy monolith was doing in the first place. So they needed someone who understood them. Enter me. I quickly explained to them that actually it wasn't so bad, and that they'd probably be better off keeping it rather than migrating to microservices. And a lot of people got very angry with me because I did them out of a job. But I did save the company a lot of money. And that's what I ended up maintaining for that 5.5 years. Recently, about a year ago, I joined a company called Personio. They're based in Germany, and they're an HR tech company. And they too have a big legacy monolith. They also attempted to migrate to microservices with varying levels of success. And I was brought on to join the international expansion team. But less than a year later, they realized that's not really where I belong, and I should have been on the platform team in the monolith developer experience. So that's where I am today. I am officially a monolith developer experience platform engineer. So, as part of my previous job, trying to explain to people that actually the monolith isn't so bad, this character popped into my head, Shrek. He is an ogre, and he is very misunderstood. And he tried to explain to Donkey that ogres are like onions. Now, I'm sure you're all familiar with the image of an onion, and you know what an onion looks like. It looks like this, and if you were to cut it in half, it has many different layers. There are levels of complexity to an onion that aren't visible from the outside, the same as Shrek. And you've probably seen a diagram like this as well. This is an architectural diagram. It's hexagonal architecture, and it too has a whole bunch of layers. And I was thinking, actually, this big legacy monolith is very misunderstood, just like Shrek, and just like onions, it has a lot of layers. So then I was like, actually, is this big legacy monolith actually an onion? So I came up with some additional evidence. It made perfect sense that our big legacy monolith was actually an onion. There are so many layers. It smells, or at least engineers act like it does. If you were to bite into it without preparation, it would leave a bad taste in your mouth. That's pretty much everyone's experience trying to work with the big legacy monolith. And also, it makes you cry. So I happen to know quite a lot about onions because besides being a developer, I am also a gardener, and I love to grow vegetables. And one of the first things I ever grew were onions. Another thing you'll notice about me is that I really love analogies. I just take them and I run with them. So you're going to have to bear with me. But here's today's agenda. First, we're going to look at the actual anatomy of an onion, or a monolith. The different architectural layers that make up a whole. Then we're going to look at how onions grow, how you would plant a seed and essentially build an onion or onion-lith that provides what you want from it, a tasty food or a good service. And we're also going to look at cooking onions to try and make the process of working with onion-liths a little bit tastier and slightly less painful. First off, we're going to look at the anatomy of an onion. If you were to hold an onion and peel off the outer papery layer, and then peel off each individual layer underneath, you end up with a little stub. I'm going to try and use this analogy to describe the concepts of hexagonal architecture. This is an onion, and this is a diagram of an onion. The layers and parts of an onion vaguely correspond to different layers of the hexagonal architecture. We have the leaves, which is our presentation layer. We have the skin, which is our application layer. The flesh of the onion is our business logic or core implementations. Then we have the base of the onion, which is our core domain model. And we also have roots, which are the infrastructure. So we're going to look at each of these layers. The first layer that you'll be aware of is the flowers and leaves. Usually when you buy an onion from the supermarket, it's not actually got the flowers or anything attached to it. They just kind of give you the bit that's tasty. But if an onion was to be seen growing in the ground, it would have a big stalk, and it has a nice round ball-like little flower. The presentation layer, just like an onion's flower, is concerned with its accessibility from the outside. It provides a way for you to interact with the onion, whether you're a bee and you're coming along to pollinate this flower, or if you're a person wandering in the woods and you think, oh, that smells nice, that might be tasty. It provides an entry point for a person to interact with the onion. The same as our presentation layer in our applications provides a way to interact with our application and our services. And it's on the outside. It's visible to the outside world and is attached to and contains all of the inner layers. I also like to share fun onion facts, or Funyun facts, if you will. Onions, if left in the ground, usually flower in a second year rather than a first year because they move between growth and reproductive phases. So a flower is a reproductive organ that produces seeds, and they spend their first year sort of growing and building that energy enough to deliver themselves to the outside world. In a standard PHP legacy onion-lith, you'll notice the flowers and leaves in the form of roots, and API endpoints, schemas, and HTML templates and views in the front end, and all those kinds of things that I don't touch. Next, after the flowers, if you were to pick an onion out of the ground, you notice that it has a papery, thin layer. That is, in hexagonal architectural terms, our application layer. It facilitates safe interactions with the system. It's not something that, in and of itself, you're going to eat. It doesn't taste good, yeah? Like, you take that bit off because you don't want to use it. It doesn't provide you any sustenance or substance. It just is a protective layer. It makes sure that interactions with the inner layers of your service or the onion are safe. In actual botany, onion botany, the dried leaves are called a tunic, and they're kind of like a thick layer that prevents attack from things like pests and diseases. It's a safety thing. Same with our application. We have an application layer that receives and directs requests and returns responses. It doesn't actually do anything itself. It just is a facilitator. It's a protector. In a monolith, you might notice this as controllers or commands to service providers. Controllers are typically, we try to keep them quite slim and quite small. They don't actually implement their logic, they just compose things. After our papery thin skin / application layer, we have our fleshy layers of the onion. This is like where things are. This is the meaty part. This is the bit that tastes good. This is the bit that provides us with nutrients. This is what performs the operations that we want our application to perform. This is the business logic. But you'll notice that onions do grow in layers. They can separate from one another. They aren't fused or attached in any way, apart from to the base. We'll talk about that in a second. They implement the instructions that are contained within the basal cells. They're implementations. In terms of onion botany, these layers are actually leaves. They're fleshy and they contain a lot of water. They hold water. It's a type of succulent leaf. Just like any other succulent plant has kind of fleshy leaves that retain water, onion is the same thing. In our monolith, this kind of fleshy business logic layer is in domain services and helpers and generally the processes and algorithms that drive our system. Then, if you were sat peeling your onion and took off all of the fleshy layers, you would notice that you would be left with a little kind of hard nub type thing from which the top or the leaves were growing, and underneath there would be roots. This tiny little stub is actually a very short but very wide stem. Just like any other plant or flower you see growing, usually plants have quite long stems with a flower on the end, while the onion stem is just that little base bit. And you might have heard of the term stem cells. They are a specialized type of cell in any organism that is capable of producing any other cell for this organism. It contains all of the information that is required for that organism to grow. And the same can be said of our core domain model. We define our abstractions. They are our building blocks upon which our monolith grows. They are the core concepts. They don't actually do anything. The stem cells themselves, like the instructions, aren't things. They're just instructions. There's no logic there. In our monolith, this comes in the forms of entities and aggregates and value objects, our interfaces, our abstractions. Then, like I said, if you were to turn that little base, the stem upside down, just like any other plant, you would find roots. Roots communicate outwards from the system and interact with the world around them. This is the infrastructure of our application. It's how we interact with things that our application requires in order to function correctly. This is, databases and things like that, servers. It is on the outside of the onion, just like the papery thin layer and the flowers and the leaves. This is on the outside. But the difference between the roots and the flowers is that the roots are hidden. They're underground. When your onion is growing in the ground, the roots cannot be seen. So that's one of the concepts of hexagonal architecture, is that you do have sort of two sides to the outer layer of your architecture, and they both communicate with external entities, but in very different ways and for very different purposes. They enrich the system. In our monolith, you might spot roots in terms of the infrastructure in SDKs, databases, RMs, frameworks, and adapters. This is pretty much everything that is provided by a third party, whether it's something that you've put on a server somewhere else and you're calling via an API, or whether it's an ORM that's provided by your framework. If this isn't part of your core domain and business logic, then it is infrastructure that is provided to you. Cool. So now we have a pretty decent idea of what an onion looks like and what all the different layers do. But how does an onion grow? How do we get from a seed to a fully formed onion? I'm going to use this analogy to hopefully explain domain-driven design and behavior-driven design. As we learned, onions grow from that base stem. That stem contains all the information required for growth. So we need to identify what that is. If you were to do a greenfield project and you decide that a monolith is the way to go, there are steps. I've created a step-by-step guide for you approaching a sort of greenfield project that you're going to implement as a monolith. Before you do anything, whether it's building a monolith or planting an onion seed, you can't just throw an onion seed out into I don't know, the concrete and expect it to turn into anything meaningful. It's just not going to happen. You have to do a bit of groundwork, a bit of discovery. You have to survey your land. You need to talk to domain experts. As Daniel said in his talk, you need to come to a common understanding about what are the needs. You need to develop a ubiquitous language. This is a DDD term that essentially means that when you're talking about something, everyone knows what you're referring to. You know, if someone in your organization calls your customers clients, call them clients, don't call them customers. Same goes for pretty much anything. There might be various different terms that people use to refer to things, and you need to come up with a way of integrating all of those. And also identify the needs of your system or the demands of the users. What are you actually trying to solve by this? Are you trying to grow spring onions for a salad? Or do you need to grow a big fat brown onion for a stew? You don't know until you've done that kind of mapping, that discovery. User stories are really great for trying to encapsulate a lot of this. Once you've figured out where you're going to plant your seed, your onion seed, well, you need to know what exactly you're going to plant, okay? The seed has enough nutrients to support an onion in its first few weeks of life. And it contains those stem cells, those instructions that are required to build the entirety of an onion. We need to know what we're going to grow. We need to know the variety of onion that we're going to grow, and we need to encapsulate all of that. Defining a shared understanding in plain English is really important. If engineers understand something but non-engineers don't, then that's, that comes lots of misunderstandings, and maybe you'll get a mutant onion, and that's not going to work. You can define API schemas. That's really helpful to define the way that services are going to interact with your service. You can also create entities and value objects. The difference between entities and value objects is that entities have a life cycle. Entities are things like your users or people. They are born and they grow up and then we won't talk about that. Ultimately, they have an individual identity and they change. Value objects are not defined by their identity, but by their properties. So if you have two value objects that have the exact same properties, then they're essentially the same thing. They don't have a unique identity and they don't have a life cycle, they just are. An example of a value object might be an address. It doesn't matter what house is built at that address, or if someone else moves into the house, your address changes because you're an entity, but the address itself remains constant. And it doesn't matter what that address is assigned to, it's the same address. You can implement these as interfaces or objects that are immutable. So you can define the properties that you expect an entity to have. And all of these value objects and interfaces that you're defining form part of your core domain model. These are the concepts and entities that everything else in your application is going to depend on in order to grow and provide the services that your system wants to provide. Once you've figured all of that out, the abstractions, it's time to implement the actual business logic. This is the fun part of growing a monolith. You get to actually implement how your services are going to do what they need to do in order to provide the thing. This is your big fleshy layers of your system. You're growing and expanding. But when you do this, remember that onions grow in layers, and so do big monolithic applications. There are bounded contexts. One thing from the core domain model in one layer means something different in another layer. The layers themselves do not interact in any way. They are completely independent and decoupled. They can be separated, and it doesn't impact anything else but the structural integrity of the entire onion. But anyway, these are your implementations. These are not abstractions. You'll probably at some point realize that you can't just have layers of an onion just sat there without anything to help support it. You will need to implement the infrastructure surrounding your monolith to support it and help it to grow. Our core domain model that we developed in an earlier step provides interfaces and abstractions. These are what is called in hexagonal architectural terms ports. They define what are the requirements of anything that is to plug into our system. It's literally a plug socket, yeah? It says, I need a plug that is in this size and shape so that it can do X, Y, Z thing. Maybe it's storage. I don't know. Then for our infrastructure layer, we need to create adapters in order to plug into those ports. So you might have a port that says, I need some kind of storage mechanism. But your adapters might be for MySQL or Redis or a file system. Any way that you want to store whatever your system needs to store, as long as it conforms to the port, as long as it can fit in the plug, you can change those however you like. So identifying those and writing the correct adapters allows flexibility. Adapters can be used for anything that you haven't personally provided as part of your application. I recommend creating adapters for things like ORMs and even logging services. There are a few sort of well-defined ports, as it were, in the PRSR framework of providing core interfaces that all applications and frameworks could adhere to essentially facilitate interoperability. It's nice to not be like Apple and force everyone to use your weird lightning port things that no one else uses. It's much better if we all just use USB-C. So, after you have your onion that's been growing in layers and has roots, you need to develop that skin. You can't just allow people to come into your application and call whatever functions they like. You have to define an ingress. You have to specify how things are allowed to interact with each other, how you can access the different layers inside the onion. Make sure you plug those adapters into the correct ports. If you don't want to use one adapter, you can switch it out. You provide functionality via controllers, and these user stories become your use cases. Everything is orchestrated within the onion itself. Then, when you're ready to release your onion or onion-lith to the outside world, you can expose the ingress points. That might be registering routes, using a router to handle HTTP requests and registering commands. And it's also at this point that you could implement a front end, but again, I don't do any of that stuff. So now hopefully you understand the anatomy of an onion and an onion-lith. And you're thinking, that's all very well and good, Katy. But I have this onion here and it's already chopped up and it's making me cry. Please help. Okay. Yeah, having just a chopped up onion with all the layers intermingling, it's a pain. Yeah, you're going to cry. It doesn't taste good. You need to cook it right. So I'm going to present to you some cooking tips. I really enjoy this book and the associated Netflix series Salt, Fat, Acid, Heat by Samin Nosrat. And it is a concept that applies amazingly to onions and onion-liths. The idea is that there are 4 elements that you need to master in order to provide good cooking or do good cooking. They are salt, fat, acid, and heat. If you apply all of these 4 things in the correct way, then that's how you get really good tasting food. And yeah, you can apply this to onions. If you were to get an onion, peel off the papery layer, maybe chop an X in it, and pour over some olive oil. Sprinkle on some salt, and then shove it in the oven for, low and slow for a while. Take it out, and you have a caramelized onion. It becomes really sweet, and it's no longer horrible to bite into. And if you pair that with the right kind of vinegar, like a bit of balsamic vinegar, in terms of the acid, you get a really tasty onion. Onion-liths, on the other hand, well, let's look at what we can do about that. The first element of good cooking is salt. Samin says that there are 3 basic decisions involving salt. When you add it, whether it's at the end of your cooking, whilst the meal's on a plate, or during cooking. How much, too little or too much, could be overpowering or not, and in what form the salt is. Salt makes food taste good, but salt, in and of itself, doesn't taste good. Like, you're not going to sit down to enjoy a bowl of salt, yeah? You add salt to other food because it improves the flavor of that food, not because salt tastes like salt. Unless you're really weird and you really like to eat salt, in which case, go ahead, I'm not going to judge you. Salt, in terms of our code base, would be things like comments. These are things that don't necessarily do anything to your code. They don't provide any logic, but they make things easier to understand. They make things tastier. Using ubiquitous language, terms that people understand, improves clarity. So I'm going to go through some do's and don'ts. Imagine that we have this interface basket, and it has an add item method that adds an item to the basket. And we have a nice doc block here, which tells us what the parameter type is. It's redundant though, right? Because we already know that. We can already infer that from the actual code. This is a case of too much salt. Yeah, like you've added salt in the wrong place. This isn't helpful. This doesn't make anything clearer. It just it confuses things. But there is potentially something missing that could be added to this doc block that we can't infer from the method signature. This is kind of a PHP thing. I think in some other languages, you can say or define as part of the method signature whether a method should be expected to throw an exception if something goes wrong. But we don't have that in PHP. But we do have our doc blocks, and we have various annotations that we can use to clarify some of the behavior or expected behavior of our interfaces. So in this case, we have a basket, and when we add an item to it, we can throw an out-of-stock exception. And adding that comment just makes it clear because, yeah, it's not obvious that that could or should happen when implementing it or using this interface. Cool. Next, we have this method that takes a basket and places an order. It has quite a long-winded doc block comment. It creates a new order for the basket, then emits an event and emails the merchant. It returns a new order if the order is successful. Otherwise, it returns a string error. I'm sure you've all seen stuff like this. A clue to something not being quite right is when your doc blocks contain words like if or else. It's doing too much. It's kind of confusing. Mixed type returns, not great. Be more specific. Make it clearer what's happening. And don't return error strings. Do something like throw an exception. Unless you're working in Go, in which case they have this other weird error thing. But you can see from this improved example, we can replace some of these wordy comments with proper typing and our comment annotations that says, yep, we're going to throw this exception if something goes wrong. Another note about comments is that when you have a wordy comment like this, it usually is explaining what the code is doing. But we can see what the code does. If you can read the code and it's not too convoluted, you can just look at the actual context of the method and see what it's doing. Don't explain what your code is doing in a comment. Explain why your code is doing. Why would someone want to call this method? What conditions should they call it under? What is the purpose of it? We're not creating an order and then emitting an event and emailing the merchant. That's an implementation detail. We don't care. What we care about is when someone places an order, like if they indicate that they want to purchase the items, then yeah, we can place an order. Cool. This is another example where we have an interface called handler. and it processes some record, and the record has some properties, which are customer details, apparently, and has a collection of items. What kind of items? I don't know. Oh, it's e-commerce checkout process. Okay. We need those comments there in order to understand what's going on, right? Like these comments provide necessary clarity, but this is the wrong kind of salt to use, okay? We could use proper naming instead. If we didn't name them generic things like handler, processor, record, props, and collection, we wouldn't necessarily need all of these comments. It's a checkout interface. We submit an order for processing. We have our order that has customer details, not properties, and it has items. Much better, right? Get rid of all of that stuff. Now it makes perfect sense. I don't need any extra clarity. It tastes good on its own. So that's salt. And if you want to go ahead and delete a bunch of redundant comments, please do. And if anyone complains, tell them I sent you. The next element of good cooking that we need to master is fat. Fat tastes good. We like it. Without fat, food would be tasteless. But too much fat and something is just kind of stodgy and bleh, and not that pleasant to eat. In our application, this fat comes in the form of bloat. Samin says that fat plays 3 distinct roles in the kitchen: as a main ingredient, as a cooking medium, and as a seasoning. If it's not a necessary ingredient to your dish, don't add it. Don't define unnecessary get and set methods. They are usually just bloat. When you add attributes, consider whether they are optional or required attributes, and beware of invalid state. When you have too many different kinds of fats or ingredients, it can get quite confusing. And also, if something is mutable, think about why. This goes back again to the why do we do things, not what we're doing. So I've got some more examples. I'm sure that you have lots of things like this where you have a class or an entity that has a get method and a set method for every property on that class or entity. But IDs are usually distinct, yeah, and they're not mutable. When an entity has an ID or a way to identify it, that doesn't change. So instead of using set methods for every single property without consideration for what the actual intent behind them is, can lead to some kind of disastrous situations. So we can use constructor property promotion. So by adding the ID to our constructor as a private read-only property, we're saying that a user cannot exist without this information. It's a required parameter. Every user has an ID. Not only do they have an ID, it's read-only. And so it can't be changed. Like once you've set it, once you create a user with an ID, that's it can't be changed. And it's private. You can't just access the ID, you have to access it via a specific method, and that would be our getter. That's fine. You could also use a public property. That's useful for the name. A user generally has a name, like everyone has a name. I'm thinking about that list of assumptions that developers make about names. I don't know if anyone else has seen that list. There's a giant list of things, assumptions developers make about names that aren't true. I know a few of those. Actually, I think you can not have a name. I think in some cultures you don't get a name until you reach a certain age, for example. So there would be no name property. So maybe that could be a nullable string. Anyway, my point is that we can use constructor property promotion here as well for name, but we're saying it's a public string name. And we don't need our set method because it's a public property and it's not read-only because names can change. That's an assumption that lots of people make. Did you know you can just change your name? If you don't like your name or want a different name, you could just change your name. That's okay. So thinking about the why. Constructor property promotion, good idea. And I'm sure you've seen this kind of thing too. This is a nice interface that defines a contract for contact details. When we have contact details for a person, that includes their address, which is formed by a zip code or a postcode, a town, a country, and also a phone number, which has an area code, country code, and also an email address. And in this interface, they're all strings. This isn't great because, well, an address might have different formats depending on where you live. Like in the UK here, we have postcodes. We don't have zip codes. So having contact details with a zip code on it doesn't make sense. But if we have an address interface, which is a value object, then we can pass in an object of that type and know that it is valid. You can't just pass in any old string to a town or, a zip code that's actually a postcode or something like that, or it has to be numeric, but we don't use numeric zip codes. That's a lot safer. It also reduces the size of our giant contact details interface. And whilst we're at it, we can do the same for phone number. And we're not just passing a string. And we can validate these things. So if a phone number has a certain number of digits or follows a certain structure, then we can define that. But be careful, because still, even in the UK, there are some area codes that are 1 digit shorter than everywhere else. And there are systems into which you cannot input those phone numbers. And that drives some people absolutely frustratingly, Be careful, don't make assumptions. Speak to your domain experts, speak to people who know about phone numbers. And whilst we're at that, we can use value objects for email, because emails do follow a specific form. They have an @ symbol in the middle. They have the user, and then they have the @ symbol, and then they have the host. And that is pretty well defined. So don't let people set a random string as an email address, because it's not going to work. It might be invalid. So that's a much better encapsulation, using the correct kind of interfaces and classes that provide us with this nice tasting thing without being too overblown. Now, when we add multiple things or multiple ingredients into a recipe, they can sometimes conflict with each other. Maybe those two things don't go well together. This is an example of that. We have a person interface, and there are methods on here that define get date of birth, set date of birth, get age, and set age. Does anyone see the problem with this? What's the point of having a date of birth if you can just set someone's age? I could put my proper date of birth for legal reasons and then just set my age to 21, because that's what I'd like to think was my age. So be careful when you're defining things like this, that you can't move your object or entity into an invalid state. I cannot have a birth date that starts with 198 and be 21. Get rid of that. We can still have get age, because it's useful to get that information. That's cool. But, we don't necessarily want people to be able to set their age, or we could say that the get date of birth is a private method because we're never going to use it outside of this method, but we allow them to set it. Depends on the use case. We're going back to the order thing now. Imagine that you have this interface. It's an order interface, and it has two methods, set status and get status. And status is some kind of an enum that contains values like shipped or processed or pending or whatever. This is all very well and good. It performs a function, but again, you're not thinking about the why. When you have an entity, think about its actual life cycle. If you can just set the status to any old status, then an order that's already been shipped could, in theory, become unshipped, but that's not really possible. So whenever you're thinking about implementing a set method, think about what you're setting and why. When you set a status of an order, you're not really setting its status, you're actually processing it or shipping it. That ensures that you can't unship an order that's already been shipped. You can add validation on the status. So inside your ship method, you can say, oh, has this order already been shipped? Yes, no. If not, then cool, we can go ahead and ship it, otherwise don't. and we can still get the status of an order. That's cool. So yes, think about entity lifecycle and why. Oh yes, and we can also change the get status to is shipped, because that's the information that we really care about. The last element of good cooking that we need to look at is acid. Samin says, we play to each element's strengths. We use salt to enhance, fat to carry, and acid to balance flavor. It's a balancing thing. In terms of our application, this complexity comes in terms of the dependencies that different parts of our application have on other parts of our application. A really good tip that I can share is to check the use statements of each of your classes. We have namespaces, and they're pretty good at defining what the different layers and parts of our application are. So if you see in the use statement that something is using something that it probably shouldn't be using, or is referencing a different namespace, you can think twice. And thinking about our onion and how the outer layers, once they're peeled off, they no longer exist. An inner layer cannot reference anything or access anything that is outside it. But inner layers are aware of things that have yet to be removed from our onion. Depend on abstractions, not concretions. This is a solid rule. Don't reference specific infrastructure. Remember our ports and adapters. And to break rules, you must first understand them. So here's a nice example of where we have some cross-cutting or things using things that they shouldn't be using. We have a shop application, say. We have our domain model defined in the shop app domain namespace. Cool. And we also have our implementations of our shop things in our shop app implementation namespace. And in our domain namespace here, we've defined interface invoice and how we can pay. We can pay for our invoice using cash. But hang on a second. There's an error in my slide. That should be implementation cache, not services cache. Anyway, the point is that this invoice interface within the domain layer is referencing something from our implementation layer. It's going the wrong way. It's going out of the onion. It's trying to retrieve layers that have already been peeled off, and that's not really possible. Instead, you should always reference the domain abstraction. If something is in the domain layer, it can only reference other domain layer items. It can't reference anything from the implementation. But our implementation can reference the domain layer because it's from the outside. So instead of requiring a specific implementation, i.e. cache, we should require generic payment. And then for each of our implementations, we implement that generic payment. So we know that it can be used to satisfy the need to pay for an invoice. But it doesn't matter whether it's a cash payment or card payment. We don't care about that. That's an implementation detail. And as you can see, we've removed this use statement that is referencing our implementation layer. All is good. Thinking about our implementations, maybe we have some kind of order stats thing that executes an SQL query, and so we can count the number of orders that we have in our system. This is referencing a specific infrastructure. We're specifically referencing MySQL here. Remembering that we should create adapters that we can plug those implementations into. So in a case like this, a good kind of adapter is the repository pattern. A repository pattern is like an interface that is responsible for collecting information from storage. Whether it's a MySQL database or an API or the file system, it doesn't matter. The point is that our repository provides this method findAll that we can then count. So if we replace that, that's cool. Let's take a look at the implementation of that repository. It probably looks something a bit like this. So we created an order repo abstraction, and we implement it as a MySQL version. We construct it using a MySQL connection, and then our getAll method performs that SQL. That's cool, but it's never a good idea to have hard-coded dependencies like this. we should always use dependency injection. If anyone is confused by the concept of dependency injection, all it means is that something is given to something from outside. So whatever creates this MySQL orders class or object has to provide it. It doesn't provide its own dependencies. It is given them. The dependencies are injected. This way, we can configure and use a different connection. We are not dependent upon this MySQL order repository from knowing which connection to use. As a last sort of thing, in terms of dependencies and layers and things referencing things that they shouldn't reference, if we remember our bounded concept from earlier, that the layers of an onion don't sort of interact with each other. They're not merged together. There is a tool that I highly recommend called deptrack. Using deptrack, you can define the layers of your application and what classes form those different layers. You can define an infrastructure layer, domain layer, business logic layer, various bounded contexts. And it's essentially a static analysis tool that tells you when layers are referencing layers that they shouldn't reference. So you can make sure that the infrastructure layer only references the infrastructure it's supposed to reference and some adapters and ports, and that ports aren't referencing adapters, etc. So that's cool. And that will help you understand the rules. And if you do decide to break the communication between different layers, at least this will give you visibility into that. And you can have a baseline file or do exclusions and say, okay, yes, I know those two things are tightly coupled together, but at least it's documented. So when you have a big legacy code base, it's okay. You can still make use of this tool, and it's really good. The very last thing, and I'm not going to spend too much time on this, is heat, is the way your application performs under pressure. Test things, okay? Apply the right type and quantity of heat for the proper amount of time, and you will turn out vibrant and beautiful food. Before you can rely on your application, you need to test it. Test implementations, not abstractions. Abstractions aren't testable. Avoid using mocks unless absolutely necessary. Use fake implementations. This makes sure your application works at a real-world scenario. And remember that implementation details are subject to change. So don't test private methods. Focus on the public actual behavior of your application, the public API. Shameless plug. I was here 5 years ago doing a talk on testing legacy code. So for more information about that subject, please go check that out. And very, very, very quick thing, because I am out of time. When we have something like this, the one thing that I want to stress is do not mock the system under test. When we're testing this method, get value on the order class, and we want to test it in our example method here, we're testing get value, and we're mocking the order. This test passes, okay? Because we're saying that the cart will return that value and that our system will return that value from the cart. But if we were to change that and change the cart to return null, we would not get the expected value. This would error. It's because we've told the test what we want it to do. Don't mock the system under test. Don't even mock objects that are dependencies of the system you are testing. Use a fake implementation. You can use anonymous classes for this, and this is a really great use of anonymous classes. They are not new, they're an old thing. Good alternative to mocks. Right. Well, quick recap then, that's Schlot. We talked about onion architecture and how your application has multiple layers. Identify the layers in your system, go install deptrack. We talked about DDD and BDD, how your application grows depends on the domain. Start from the ground and work up when you're implementing new functionality or working on greenfield projects. Clean coding. Applications taste a lot better when you master the elements of good cooking. Delete those redundant comments. Refactor, use dependency injection. If anyone complains, send them to me. You have my permission. And if you have feedback, please let me know. I'm joined in, and you can contact me. I will be sort of mingling around at the conference and on Mastodon. That's it. Thank you.